Now we're looking at the derivative of f of x is equal to x to the power of n for any positive integer n. So graphically, I would want to show it over here. So we have x cube over here. That would be your graph. So basically it would be something like, actually past the x 0, it would be something like that. Now, how will we find the derivative of this? The same process as per the first principle. Of derivative. We are looking at f dash of x is equal to f prime of x is equal to limit f of x plus h minus f of x, this entire expression divided by h, and this is h tending towards 0. So basic funda is we'll take x over here, x plus h over there, and we will take the respective value along the x, along the graph to represent the y component. So over here there is a very specific thing, that being f of x plus h. So we are considering f of x plus h. What is f of x plus h? F of x is x to the power of n. Here it would be x plus h whole to the power of n. That is, we are replacing x by x plus h. Agree? So basically this point is x comma f of x, right? So basically f of x over here is what? X to the power of n. So this is basically x to the power of n. And this point would be x plus h comma x plus h whole to the power of n. Does it make sense? It should. It's just a matter of substitution. That's it. Now we need to expand this. How will we expand it? Using our binomial expression a plus b whole to the power of n. We need to write the formula a to the power of n plus nc1 a to the power of n minus 1 into b to the power of n, and the last term is, sorry, this is b to the power of 1 and this is b to the power of n. And when we expand this expression, we will get the following, which in turn is equal to x to the power of n plus x to the power of nc1 is n times of x to the power of n minus 1 into h, plus the last term is h to the power of n. Now we have to go back to this, so we need to substitute, say 1, or substitute the above in 1. We'll call this as a. Substitute 1 in a. Let's substitute 1 in a. Okay, so we have f prime of x is equal to limit x to the power of n plus n times of x to the power of n minus 1 into h plus h to the power of n. This is what? This is your f of x plus h. Then we have minus x to the power of n. Okay, so please understand this. This entire expression is your f of x plus h, and this is your f of x, and we have this getting divided with h, right? So this is your first principle of derivative. I wrote the expression for f of x plus h, that's in green, and f of x is in red. Now, can I cancel something over there? Clearly, this and this. And the remaining terms are basically limit n into x to the power of n minus 1 into h plus so many terms, and the last term is h to the power of n. This entire expression divided with h, and h tending towards 0 over here. So what is common in all of this? Yes, x will be common. Sorry, not x, h will be common. X is not present in the last term. So h is common, and we have h times of n to the power of, n into x to the power of n minus 1 into 1 plus, and the last term will be h to the power of n minus 1. Agree? I'm just taking common. And now we have h and h getting cancelled and direct substitution of h. So what do we have? We have this to be n into x to the power of n minus 1 plus 0 plus the last term being 0. And finally our answer is n into x to the power of n minus 1. So that is your derivative of the given function. Let me take an example for you guys. Say y is equal to x to the power of 40. So we have the derivative of this would be equal to 40 times of x to the power of 40 minus 1, that is 39. In our question actually we have taken 3, right? Let me take the actual value so that we can verify with the graph. So 3, so this will be 3 to the power of 3 minus 1. So basically this is 3 into x square. So if I take a specific value, let's do it end to end. At x is equal to 2 basically. So this would be 3 into 2 square. So that will be 4 and 12. The slope would be 12 at 2. So let's check that out. Almost there, and yeah, I think 2.008, that's good enough. You can see that it's 12 approximately. So this works. And this is your derivation. And by the way, diagram is not required. It's only for understanding. Your answer starts over here. Proof starts over here. It's not meant for your exam. It's only for understanding.